Hey everyone, today's lesson is going to focus on energy transfer. By now, we've already learned what a food chain is, and so I've given you an example of a food chain. We know we always start with the producers, and the producers get their energy from if you thought sun, you are correct. So producers get their energy straight from the sun when they undergo photosynthesis to create their food, which is glucose. Next up in our chain is a grasshopper. We know that the grasshopper is going to be eating the grass to obtain its energy. The grasshopper is known as our primary consumer. Primary consumers are most likely always going to be herbivores. Why? They eat producers. Following the grasshopper, we have a mouse. The mouse eats the grasshopper. Therefore, this is going to be our secondary consumer, which is also a carnivore. Depending on the size of the food chain, you can have multiple consumers. In this case, we have a tertiary consumer, which is the snake, and a quaternary consumer, which is the hawk. But even though we know how energy is transferred from one organism to the next, how much energy is actually being transferred? And that's what today's lesson is going to be about. We understand how much energy is transferred from one organism to the next by following the 10% rule. The 10% rule states that only about 10% of the energy in one level of a food chain is going to be transferred to the next level. That means only 10% of the grass's energy will be transferred to the grasshopper when it eats it. Energy units are seen as kilojoules or kilocalories. What I'm going to show you now is how to actually calculate 10% of energy. The good thing is, it's easy. All you have to do is move your decimal point 1 over to the left to calculate 10%. Let me give you an example that I have already done. I use the same food chain that you've seen since the first slide, and you're going to notice that there's energy numbers at the bottom. We start from 100,000 to 10,000 to 1,000 to 100 to 10. Each of these numbers represents how much energy each of these organisms will have. And as you move from one level to the next, you're going to notice that they have 10% of the energy from the previous level. Now, if you see the picture to your right, you're going to notice that I worked it out for you. When calculating 10% of a number, all you have to do, like I mentioned before, is move the decimal point 1 to the left, and you've officially calculated 10%. Now, even though the number might not have a decimal point, you know the decimal point always comes at the end. So go ahead and just add it in and move it 1 to the left. That is how I calculated the energy seen in each of these levels. So what happens to the other 90%? And why does only 10% of energy transfer from one level to the next? Well, the reason why we only get 10% of energy from things that we eat is that the other 90% is lost to the environment as heat. We can see this food chain also be represented in a different model. These models are called energy pyramids. An energy pyramid is a model that shows the flow of energy from one trophic level to the next in an ecosystem. So at this point, you might be thinking to yourself, well, what is a trophic level? A trophic level is literally just the level in the energy pyramid. Starting from the bottom, where the producers are, that will always be your first trophic level. Producers will always be found in the first trophic level, and you will move up to the second trophic level, where the primary consumers are. the third trophic level where the secondary consumers are, and the fourth trophic level where the tertiary consumers are. Now, something that might trick you or confuse you is that the second trophic level belongs to the primary consumers. So you kind of have conflicting numbers here. We have primary, which means 1 in the second level. So make sure that you're not getting confused and you're thinking about what organisms would be found in each level. Therefore, in the second level, you will always find primary consumers. Also, I want you all to notice the model. In an energy pyramid, we're very strategic in using a pyramid. And that's because as you move up the triangle, what do you notice about each level? Well, if you were thinking that the level is getting smaller, you're exactly right. As we move up, each level gets smaller. But what's actually getting smaller? Well, 1, the amount of energy that is going to be found in that level. And 2, the number of organisms that's going to be supported in that level. So, producers will always have the highest number of organisms and will always have the highest number of energy. And that makes sense because producers get their energy directly from the sun. Here's another example of an energy pyramid. You're going to see that it starts off with the producers and moves up to each level of consumer. What I've added to this energy pyramid is going to be the 10% rule. You're going to see that the producers start off with 100% of the energy. When you move up a level, the primary consumers now only have 10%. How did I calculate that? Well, just as before. I add in my decimal point and move it 1 to the left. So let's practice. If the producers have 10,000 kilojoules of energy, how much do the secondary consumers have? So, if my producers, which are the bottom of this pyramid, contain 10,000 kilojoules of energy, I need to figure out how much the secondary consumers will have. So I'm moving from the first trophic level to the third. That means I'm going to have to move my decimal point 2 times to the left. I take my number 10,000, put my decimal point at the end, and I move it over once to the left. That's going to give me the number 1,000 kilojoules. That's how much energy the primary consumers have. But remember, the question's asking about the secondary consumers. So I have to move my decimal point 1 more over to the left. When I do that, I move my decimal point over again, and now I have the number 100. The secondary consumers have 100 kilojoules of energy. Let's try another one. If the second trophic level has 100 kilojoules of energy, how much does the fourth trophic level have? At this point, I want everyone to pause the video and work it out on their own. Go ahead and press play when you're done to check your answer. So looking at my second trophic level, that is where my primary consumers are. This question is telling me that the primary consumers have 100 kilojoules of energy. And I'm trying to figure out how much energy the fourth trophic level has, which are the tertiary consumers. That means I need to move 2 levels up. So I need to move my decimal point 2 times to the left. I put my decimal point at the end of the number 100 and move it over 1 to the left. That's going to give me 10 kilojoules of energy. But that's how much energy the third trophic level has, or the secondary consumers. This question is asking for the fourth trophic level, or the tertiary consumer. I move it over one more time to the left. That's going to give me the answer of 1 kilojoule. Let's try another one. The question says, if the tertiary consumers have 0.01 kilojoules of energy, how much do the producers have? Well, at this point, you're going to notice that you're going to have to be working backwards, right? Usually, up to now, we've calculated energy transfer going up the pyramid, from first trophic level to second to third to fourth. But this time, we're moving from the fourth trophic level to the first trophic level. Well, we need to work backwards. So, usually when we move up the energy pyramid, we move the decimal point 1 to the left. However, now we're going to be moving down the energy pyramid. Can you guess how you're going to be calculating these answers? Well, if you said by moving the decimal point to the right, you are correct. So go ahead and pause this video and practice solving this problem. When you're done, go ahead and press play to check your answer. So my tertiary consumers have 0.01 kilojoules of energy, and I have to move down to the producers. That's 3 levels down. That means I'm going to have to move my decimal point 3 times to the right this time because I'm working backwards. So I take the decimal point at the front of 0.01 and move it over 1 to the right. The secondary consumers will now have 0.1 kilojoules of energy. I take that decimal point and I move it again 1 over to the right. My primary consumers will now have 1 kilojoule of energy. And finally, I take that decimal point, which is now behind the 1, and move it over 1 to the left. I mean, not to the left. We're working backwards, right? So I'm going to move it 1 to the right. And when I move it 1 more to the right, I'm going to now have to add in a 0 in that empty space to make 10 kilojoules of energy. That means the producers have 10 kilojoules of energy. You are officially ready to complete your assignment. Now, if you're still a little bit confused on how to calculate and use the 10% rule, don't hesitate to reach out to your teachers for help. That's why we're here. Good luck, guys.